All right, let's get into building the particles. So the particles, first off, when we make a particle object, we create a new particle object with by instantiating a particle class. We are going to be passing a couple of variables in it when we construct it. So the variables are going to be the x position of it, the y position of it, of the particle, the radius of the particle, the rate of change in the x direction of the particle, basically the speed, the rate of change in the y direction, again the speed, and then the life of the particle, L, and the hue, if I'm not mistaken, so the color of the particle when it first starts. Why am I doing it this way? Why am I using the shorthand when I described earlier about being descriptive? Is because this is redundant. In the init particles function, I'm going to be using descriptive variable names. So this is redundant to have them. So rather, I would prefer to have shorthand here. So if we just go, because this is a class, we could go this dot x equals the x that's passed into it. This dot y equals y. This dot r equals r. This dot rad. Now this one's interesting here because these are oscillating a little bit. If we go here and look, you can see that they're kind of moving back and forth. So if you follow it, it may take a while. Some are moving at a quicker rate than others, but yeah, they're moving. So yeah, this is due to the radians. So we're gonna go and we're gonna call my rand function here, and we're just gonna say 0. So we want it to start the radians position. We want it to start at a random value between 0 and 2 pi. So anywhere along the circle is basically what's happening. This dot dx is equal to 0, or let's just say dx. Oh, yeah. It was dx, and this dot dy is equal to dy. And this dot L, the life of this thing, because these are fading out. Again, if you see here, they're slowly fading in color. Now I've made the change really subtle, but if you saw that one disappeared, that one disappeared, this one's in the process of disappearing. They're slowly fading in color. They're fading out. So this is the life parameter, or this dot L, the L parameter. So I'm setting that, and then finally the color. This dot H is equal to H. All right, and so those are all the properties that this object is going to have. Then there are the methods, or the functions. This dot init is going to equal a function. And just like before, we are outlining this to make it easy for us to fill it in later. The best thing and the hardest thing that I learned was, when it came to like learning to develop how to code myself, was how to plan things out properly from perspective. So dividing what you want to do, what the objective is, what you want to accomplish, into how do you feasibly do it, what is the approach that you're going to take, and then outlining that approach and constructing the separate parts for it. So what does it take to actually do this, and what tools do I need? And this is where these functions come in. So again, so I have an initialization function, which is going to initialize some stuff with each particle. It's not a real constructor function. It's just whenever I want the particle to reinitialize. So for example, if you have the particle, it goes here, and then it's going to reinitialize at the top. That's how this is continuously looping. And so that's what this function is going to take care of. You have the draw, which is going to draw it every time. And this is called in the animation so that it's visible and you can see the particle. And then there is the update, which is basically going to change the values for the particle, and that's how its position will change based on what we give it in terms of speed and things of that nature. And then there's the last one, which is this dot check bounds. And basically this goes and will compare, I am writing these poorly. This will compare the position of the particle relative to the canvas to determine whether it needs to be reinstantiated or not. So for example, or like the example is that when we look at this, if the particle goes off further than where the canvas is actually set up, right? If the particle goes further than where the canvas is actually set up, it's going to reinstantiate. So we're checking the bounds there. If the particle fades and disappears, like that one there, it's going to reinstantiate. So that's what the check bounds function is doing, is that it's checking those limitations that will say, hey, if this happens to this particle, then do something about it, reinstantiate it. So that's basically it. That's the outline for the particle function. Now we're not going to fill everything in here. We are just going to leave it as is for now, and we're going to initialize the actual particles so that we get a understanding as we're going through filling this in, right? We set this up. Now let's set up the init particles, and then we'll slowly fill in the details for each as we go. All right, so now for the init particles.